Hello, everybody. Welcome to the second half of Automotive Electrical Systems. And today we're going to show you how to use a multimeter. This multimeter has a voltmeter and an ohm meter built into it. We're going to show you both functions and how to use those. This particular meter is about $140. All of the tests that I'm going to show you today and the usage could be done with a $15 to $25 meter. This just has a lot of other functions that are used in the industry for professional technicians, and it's also extremely durable and is really made for every single day use, and it's extremely accurate. So, but again, all of the things we're doing here today, you could do with a much less expensive meter. We're also going to show you how to use a test light to check a fuse in a car here behind me, and we're going to be using the voltmeter portion of this to check the voltage of this small little 12-volt utility battery, some household batteries, and we'll be using the ohm meter portion of this multimeter to check these fuses here that are in front of me. We're also going to do an ohm meter resistance test on this coolant temperature sensor. This coolant temperature sensor came out of this Toyota 4-liter V6 fuel-injected engine, which I'm a big fan of. And we are going to check how much resistance this has. So that'll be kind of neat to see, and we'll use the ohm meter portion of the meter for that. We're also going to talk about the numbers that are on top of the battery and what they mean. I'm going to show you the inside of this battery. I can take the top off and we'll see what it looks like on the inside. I've got an alternator over here. We're going to take a look at that. Got a computer, a voltage regulator, and a starter motor. We're going to take that starter motor, put it on the bench here, and we're going to bench check it. We're going to see if we can't fire that up and see what that looks like when it's actually operating. So without further ado, let's take a look at how to use the voltmeter in this multimeter. Okay, here we are. We've got our multimeter here, and I've got a test light here. I'm going to show you about how to use this test light first. We'll be using this on the car as well, but let me show you how we hook it up here to just like a small utility battery. We just hook up the clip to the negative post, similar to what we'll do on a car. And if you want to know if something has power, electricity to it, we just touch the other end to a terminal. This one right here is the positive post of the battery, and I have a good connection here. If I didn't have a good connection, I'm gonna have nothing, right? If you wanted to see if you had ground in a car somewhere, you would hook up this end to the positive post and try touching for grounds, and when you find a ground, the light would light up. But 99% of the time, for most of us, we're just going to hook this to the negative post, and we're going to start checking for power. And we're going to use this to check for a good fuse or a bad fuse in a car here in just a little bit. So that's the test light, pretty simple there. You can get these for under $10, Harbor Freight, places like that. You can spend lots of money for these things, but even an inexpensive one will do just fine for home use. Okay, here's our multimeter here, and what we're going to do is make sure we turn it on to voltage. And what we want to have here is DC voltage. We want to see DC here in the corner. That's direct current. That's what we'd be using on a car. If you're at home and you want to check the voltage coming out of your wall socket, you can put it on AC right there, and you can plug it into your wall socket and see how much voltage you have coming out of your house voltage there. So we're going to use this on DC. There we go, just like that. This has a little background light we can turn on and off. And here we go. It's pretty tough. We just take the negative terminal here, put it to the negative post, and the positive to the positive. And this battery has 12.2 volts. That's good. A fully charged battery, a fully charged 12-volt battery will have about 12.6 volts. So this is in pretty good shape here. If you happen to hook this up backwards, no harm, no foul. Reads the same thing, but as you notice, it's got a little minus sign. Got a little minus sign right there, indicating that you have it hooked up backwards. But the voltage is still the same. So there you go. All right, let's check some household batteries here. I've got a little Duracell 1.5 volt battery, and let's check the voltage on that. 1.54. Again, if I had it hooked up backwards, 1.54, but we have a minus sign in front of the 1.5. So No big deal. So if you have a flashlight, you don't know if your batteries are good, bad, or indifferent, you can take them out of your flashlight and check them out. Okay. This is, we're all familiar with this, a little 9-volt battery, but let's check that, see what we got here. Hey, 8.9 volts. Not quite fully 9, but pretty close. It should still work for a while, right? Okay, I got a lithium battery here too, with these calculators or some big watches or something. You can check the voltage on these also. This one says 3 volts on it. So, and it has a plus and a minus on it. So I can take my positive lead, put it on the top, and put the negative lead on the bottom, and look at that. Got 3.083 volts. This lithium battery is good. Should be no problem whatsoever. So you can do these checks with a $15 to $25 multimeter at home. It's kind of nice to have one around for checking things like that. And most of those will also have the ability to go to AC, so you can actually check an outlet in your wall. Okay, so that's how we use a voltmeter and a test light. So let's move on to ohm meter usage of the multimeter. Okay, let's get ourselves set up to use the ohm meter portion of this multimeter. What we're going to want to do is turn this to ohms, which is right there. Okay, got a little ohms symbol there. Line that up with that. Okay, that'll give us our ohms. And I'll turn the background light on there a little bit. I have some different fuses here to begin with. I have one here that's a 100 amp fuse. It's right there on the top. It says 100. Here's one that says 60 amp fuse. Here's one that's 7.5. That's pretty small. And look at this. This is actually physically smaller, but this is a 20 amp fuse. And here is a 10 amp fuse. So anything more than 10 amps of current that ends up going through this fuse will melt this little strip inside here and won't allow current to continue to flow through this fuse and to the device that it's protecting, whether it's a radio or wiper blades or headlights or tail lights or brake lights or something like that. If this 10 amp fuse were to blow, don't just go put a 20 or 30 amp fuse in there hoping that it'll fix the problem, because it won't. The current may go through here, but it may end up burning up the device that's further down the line, like tail lights or a radio or cruise control or something like that. So always replace a blown fuse with the size that the manufacturer recommends. You can find that in your owner's manual. Make sure you're putting the right fuse in there. So back to this. Let's see how we check these with an ohm meter. We're on ohms. We take these leads, it doesn't matter which way you go, and we touch the device, the little leads here. Nothing's happening here, right? So that must mean that this fuse is open. So that is blown. If it was a good fuse, would show something like that, like 0.2 of an ohm. That would be the same thing as if I took these connectors and put them together. Look at that, reads the same thing, 0.2. So if I set it on here like that, it just goes without saying that that obviously must have a good connection through there, right? So if you kind of forget how that works, just use that little trick right there. All right, let's check this one. That's open, right? It's just like having my leads in the air here. There's no connection, right? And this one here, no good. And this 20 amp one is good. Okay, fantastic. All right, so what I want to do now is, this is my little third hand, my little helper here. I want to check the resistance in this coolant temperature sensor. This sensor sits in the coolant and sends the resistance changes in it. And the computer reads this sensor and helps determine the air-fuel mixture ratio going into the engine. So this is around 2,000 ohms at room temperature, which is about right. And if it heats up, it should go down in value. I'll just use my hand here, my finger, and I'll heat the sensor up. And you can see the ohms are going down. Now that little K over there, right there, that's 1,000, okay? So that's 1,845 ohms, 1,840 ohms, et cetera, okay? That's what the K stands for, 1,000, okay? So there you go. I take my hand away, it's starting to go back up to room temperature, and we're going to get closer to 2,000 ohms here probably here in a second. So that's coolant temperature sensor. That's, again, what helps determine the air-fuel mixture ratio going into your engine. So let's go check a fuse in a car right now. Okay, we're out underneath the hood of this Honda Accord, and I have a voltmeter here, and I have a test light here. And we're going to start checking a fuse underneath this cover right here where the fuse box is. But first, let's use the voltmeter to check the battery of the car, make sure we have something good to work with. Again, I have it on DC volts there, right? It says DC right there. And then what we're going to want to do is, this is kind of a little hint there for you, put the probe on the top of the post and on the top of the negative post. So right on the top of the positive and on the negative. I wouldn't go on the sides. Sometimes there's corrosion between the post and this terminal here, and you'll get a false reading. Actually, that would mean that you might want to clean the terminals here. But for the sake of what we're doing here, let's put it on the top of the post on both of these. That'll give us our most accurate reading. And the battery voltage is 12.03 volts. I have the ignition key on, and it's been on for a little bit, so it's not fully charged anymore. If it was, it would be around 12.6. So we'll check the voltage in the battery when we're done here. We'll start the car, and we'll see where we're at. Okay, so test light. We're going to use the test light to check the fuses in here. Hook up the connector side of the test light to the negative cable right here. And before we start testing the fuses in here, always make sure you touch a known good positive point. That would be on the top of the battery. Okay. At least I know that my test light works, and I know that I have a good connection on my negative terminal over here. Okay. All right. So now we can test the fuses. So in this case, the customer came in, and they were complaining that the engine was getting hot, maybe even getting almost overheated when the air conditioner was on. So we might want to check a fuse for the cooling fans, which are out front here. So what we can do is, and on Honda makes it kind of nice, you take off the little cover here, and on the bottom they give you a roadmap of what fuses are for what. Okay, so this row right here coordinates with this row of fuses. So if you want to know what fuse that one is, you can go right onto here and it'll tell you what it goes to. If you want to know what these relays and fuses goes to, you can look at the top here and it'll tell you what they control. It's kind of a nice little feature. If you don't have this, you can always look in your owner's manual. Some fuse boxes will have them on the top, but Honda makes it kind of nice. They're right here on the bottom. So I'll show you what that looks like. And they're abbreviated sometimes, so they're kind of hard to read. But we got like a backup light right here, backup fuse, right headlight, low beam, right headlight, high beam. I don't know if you can see that. Small lamp, etc., etc. I'm looking for the cooling fan. Look at that. There it is. Cooling fan right there. Should be a 20 amp fuse, right? Is that what that says? Cooling fan. So if I go like this and I look, I can see that it's right here. And that's where it shows it right here in my little box. All right. So that's kind of a nice deal for Honda to do that. So the key is on, the air conditioner is on, and I can start testing either side of the fuse, okay? They got a little bimetal strip that sticks out of the top of these so you can test them, right? So if I touch on the top of that, I know, well, I got power to one side of the fuse, don't I? Let's check the other side. You press right here on the top, and I have nothing, okay? Power and nothing. It's a lot easier with a test light. If you want to use a voltmeter, you sure can. It's a little more cumbersome. You'd hook this to the negative post and touch the fuse on each side and see what you got. 11.73 on that side, and basically nothing on the other side. Got a little bit of a back feed coming through there, so there's just a little bit there. But a test light's really quick and easy to do. So I don't know if the fan works or not. I have no idea, but this is a really quick, easy test. And what I'll do is I'll change that fuse. That's what we're going to do. 20 amp fuse is blown, so I need to change it with a 20 amp fuse. Honda, in their infinite wisdom on this one, actually gave us a couple of blank fuses in here, some extras right there. So I can look on here and see, oh, I got an extra 20 amp fuse and an extra 15 amp fuse here. They gave me spares, which is kind of nice. And another nice thing they did is they gave us a little fuse puller right here. So you can take this, nice little fuse puller. You can go down here and you can pull the fuse out. Now, should we check it? Should we bench check it to see if it's any good? Let's do that. Okay, so we can set the fuse here in our little tray, if you will, and we switch this to ohms, right? Switch it to ohms, and let's touch each side of the fuse, and it's open, right? It's just like this. No good. All right. So throw that fuse away. So let's take our spare fuse out of here. It's 20 amp. Before we put it in there, think we ought to check it? Absolutely. We don't want to. I've had a new fuse before and it was faulty, and boy, I'll tell you, you end up chasing your tail all over town. So let's check it, make sure we got continuity. Oh, definitely, there's a connection there, right? It's the same as going like that. Means the same thing. So I know that that little strip of metal in there, that little tab is good. All right, set that aside. Let's install this thing right into here. This is where it goes. And I hear the fan come on. Yep. I don't know if you can see that. Right here, there's a fan going. Let me unplug this so you can see it slow down. Right here. Okay, so that's a coolant fan that comes on when you turn the air conditioner on. Okay, see that? Kind of cool, huh? Okay, so there you go. Now that works. So we basically fixed the problem there, didn't we? Well, let's take a look. Let's start the car and let's see what kind of battery voltage we have with our voltmeter. Again, you can use your standard $15, $20, $25 voltmeter. This will do everything we've been doing here. So I'm going to start the car and we'll check the voltage. Okay. So we'll put the negative on the negative post, positive on the positive. Change this to DC volts. Not going to work on ohms. I'm going to change it to DC volts. On here, and there we go, 13.87. Remember we said, well, I'll tell you what it should be is somewhere between 13.5 and 14.5 volts. So we know that the charging system is working as well. There you go. We fixed the fuse. We checked the battery. We actually checked the charging system as well. We know that's working. So not too tough to do right there. Okay, let's go take a look at a battery and take a look at the inside of the battery. Okay, so here we go. We've got a battery here. This is just a demo battery, and it has a bunch of numbers on here. Let's go over those. I've got 550 cold cranking amps, 700 cranking amps, and 270 load test amps. Okay, so let me explain that to you. This battery is tested and can put out 550 cranking amps of energy at 0 degrees outside. If it's 32 degrees outside, it can put out 700 cranking amps. Does a little bit better when it's not quite so cold. And if we were to load this with an older battery checker, we could load it at 270 amps and measure the voltage coming out of the battery and determine whether or not the battery was good or not. We have newer equipment now. We test it a little safer, a little quicker, and very accurate, and I'll show you that here in a little bit. Okay, 24, that would be the group size of the battery. There's group 24, 24F, 27, 31, 35, 60, you can go on and on. There are lots of group sizes of batteries. And if you need a battery for your car and you don't have a group size number on it, you just need to know the year, make, model, engine size, and the auto parts store can help you get the right size battery. The second number is the warranty on the battery, 60. So that would be 60 months. All right, you can get these 72 months, et cetera, 48-month warranty. Of course, you're going to pay more for more month warranty. You can also get your same physical size sometimes in higher cold cranking amps. If you're in a colder climate and your battery takes a beating, you might want to get a battery that's a little bit stronger than the standard version here. Of course, that's going to cost you a little bit of money too. Okay, taking a look at the rest of the battery here. On the top, we have a plus and a minus, so this must be the positive post and the negative post. But if these were covered up with the cable here and then a cable across here, you might not be able to tell. I wouldn't always go by the color of the cable because you can buy just replacement cables of any color. What you want to go by is the size of the post. On car batteries, truck batteries, the positive post is always bigger in diameter than the negative post. Okay, so if you're not sure, look for the bigger post. Okay, if you're going to replace a cable end, something like this, or a whole cable, or if you're just going to change maybe just an end piece like this, before you put this all back together, you might want to clean off these posts, and you can use one of these wire brushes here. They got one for the posts and one for the actual cable end here. Okay, you can do that. One here. Okay, you can clean up the cable ends, get them nice and shiny. You can always use something like this as well. This is another battery terminal cleaner. Okay, you can scrub it up there a little bit. You can do the same thing here. Go around here and get these all nice and shiny and clean. Okay, this is the heart of the electrical system, and we want to have a really good connection there. All right. So when you go to put your battery terminal end on, for example, and it goes like that and it doesn't quite fit, as you can see, it doesn't go all the way down there. Let's not go for our favorite tool, our vice grip, and start beating on this thing. What will happen is, and I've seen it happen before, is the post will actually come out of the bottom of the battery here. It'll come out, end up down in the battery, and the battery's no good anymore. Okay, so what we have is actually a battery terminal spreader tool right here. We can take this, put this in here like this, squeeze the handle, safely, there we go. Now we got a good, it's all the way down on there, right? Now we can tighten it up with our wrench, right? And away we go. Okay, make sure we get a good connection there. If it's dirty around here, also another thing, you can put a little baking soda, get an old toothbrush, a little bit of water, scrub it all off there. Make sure you clean it off really good with water, because that acid is very, very, very bad, and don't get it on your skin, it'll burn your skin. This battery also has a little built-in hydrometer right here, and if you look down in there and it's green, that means the battery is sufficient for testing, and if it's black or dark, that means it needs to be charged. I don't really trust these things a whole heck of a lot, but they are a little bit of a guide. These sit down in a bath of sulfuric acid and water. The sulfuric acid fills up all these slots here, these cells, and usually the level is right around in here, okay, on each one of these cells. Okay, we've got a fully charged battery would be 12.6 volts. We would have another one of these over here for the other side. But again, this is just a demonstration battery. So we'd have 2.1 volts per cell, and if you add it all up, you got 12.6 volts. Okay. These are positive and negative plates here that sit down in the acid bath, and they have insulators in between the plates so they don't short out against each other. If one of these were to short out, you might end up with about a half a volt in this cell, and you might end up with 2, 2, 2, 2, and 2, and you wouldn't have enough to start the car. So that's what those sit down in. That's what it looks like on the inside of the battery. These get connected, and you end up with 12.6 volts, like I said. Okay, so that's that. So I was going to show you a new tester that we use. This one happens to be from Snap-on, and this is really good. I have a battery sitting off to the side over here. The cables are already hooked up to, and I've already entered in the information about the battery. It needed to know the cranking amps and all that information, whether it was in the car, out of the car, and now it needs to know the temperature. So we'll tell them it's about 75 degrees. And now it's testing the battery safely. effectively.
Good recharge.
And I don't know if you heard that or not, but it said good recharge. Okay, well, that gives me all the information there. And the nice thing is I can print this out for folks in any language that they want. Okay, and I look a little more professional, having a little bit of a printout here to hand the customer and let them know that their battery, this particular battery, is good. And it just needs a little bit of a recharge. Good recharge. So that's what it looks like on the printout there. It's got 12 volts, and of course we know a fully charged battery would have 12.6, so it's pretty close. But it measured 281 cold cranking amps, and it was rated at 300, so that's pretty doggone good. And now we can hand this to the customer and let them know. We just need to charge it up a little bit, and we're good to go. So that's the battery, what it looks like on the inside, what the numbers mean on the top. Let's go to the charging system. Okay, here's an alternator. This is pretty typical looking. This one's out of a Ford, and this one actually says it's capable of putting out 95 amps. I don't know if you can see that there or not, but it says 95 amps. Okay. So this bolts to the front of the engine, and we have a serpentine belt that sits on here like this. Okay, goes in the grooves there of the pulley, and this other end goes to the crankshaft of the engine. So when the engine starts up, the belt turns the pulley, the alternator spins around inside and creates current. Here's a big post on the back of this alternator, and the biggest post usually has a cable that goes from here to the battery, so the battery can get the charge from the alternator. There's also a wiring harness connector here as well to the voltage regulator. This voltage regulator makes sure that the battery doesn't just keep getting charged past 14.5 or 15 volts. We don't want the battery to get 15.5, 16, 17, 18, 19 volts. It'll burn up, it'll smell really bad like rotten eggs, and it'll destroy the battery. So we need to have something to regulate how much output this alternator puts to the battery. Back in the day, they used to run these, I'll call it a mechanical voltage regulator, if you will. This is a Motorcraft as well. And it had a 4-pin connector going to here. General Motors had the same type of thing. They just had different numbers and letters on here versus what Ford had, and Chrysler had their own design, et cetera, et cetera. And these were bolted out underneath the hood separately from the alternator. Then they decided to get rid of these and go to an electronic voltage regulator, which is what this Ford Motorcraft alternator has on it. And this is a replaceable regulator should this go out. Again, if it were to go out, cause the battery to overcharge, the battery would go bad. And if it goes out, if it shorts out another way and it doesn't allow any current from the alternator to go to the battery, then the battery, of course, would go dead. A way that they do it a lot nowadays is they take the regulator out of the back of the alternator, where it generally can get pretty warm underneath the hood, and they'll put the regulator internal inside of the power control module. So it's actually inside here, doesn't heat up quite so much, and they have a tendency to last quite a long time. Very, very, very rarely do you need to change a regulator or the computer for that matter. So that's the charging system there in a nutshell. Let's move on to the starter motor and see if we can get a starter to activate here on the bench. Okay, here's a typical starter motor here. This one has the solenoid attached to the starter. This big post here would have a cable coming directly from the battery right here at all times. And the wire that would go to here would go to your ignition switch. So when you went to go turn it over, you'd have power right here. That would energize the solenoid and allow the starter to start spinning. And when it starts to spin, the gear comes out to here. I'll show you this manually here. Okay, it comes out like that, all right? Just like that. And what is it, what's it doing that for? Well, what it ends up doing is that ends up connecting with the flex plate gears, the teeth here, excuse me, the teeth. If you have a manual transmission, this would be called a flywheel, but this is a flex plate on the back of an automatic transmission. This whole thing gets bolted to the back of the motor, the back of the crankshaft. So when the starter sits like this and the gear comes out, you can see it will end up meshing with the teeth of the ring gear here. Okay, when it does that, the flywheel or flex plate spins, cranks the engine over, and spark plugs spark, and the fuel goes into the system, and hopefully the engine starts. So in a nutshell, very basically, that's how this works. All right, so teeth of the pinion gear on the starter go against the teeth here. Okay, so bench check these. You can take one out of a car. I already have a battery, 12-volt battery sitting off to the side, and I'm going to hook a negative cable up to the case of the starter. Okay, and I'm going to hook up a positive lead to the positive post here. Now I'm going to, once I do that, I'm going to jump across these two terminals right here with a screwdriver. You could use a fancy dancy switch if you'd like, but we'll just use a screwdriver today. And we'll see if we can get the starter to engage. Okay, might not be able to see it once I set this down here. So, okay, so I got power here. Right, here's our gear, our pinion gear, and I'll short across here and we'll see what happens. Okay, see the pinion gear comes out, and once the engine starts, the ring gear gets going faster than the pinion gear, and it will just disengage, and the pinion gear will go back into its little home right here where it is at all times unless you hit the key. So I know it's kind of noisy, and the speaker might shut, or the microphone might shut the noise off here if it gets too noisy, but you get the point. Okay, that's how a starter works in a nutshell. Okay, well, hey, thanks for watching, and hopefully you've got a little more understanding of the car's basic electrical system, consisting of the battery and the charging and the starting system, and how to use some basic tools like a volt-ohm-meter and a test light, so we can check fuses. You can check your voltage in a battery while it's just at rest. 12.5, 12.6 volts would be good. Heck, you can check all kinds of batteries at home now too with your volt-ohm-meter. We can also check the voltage at the battery while the vehicle is running, and we need to know that's around 13.5, 14.5 volts, something like that. So hopefully we got a little some out of this to you, and until we see you again, take care. We'll see you.